atoms, ions and isotopes. Now with the atoms, ions and isotopes part, these are 3 whole sections jammed into one video, so you may have to pause or repeat because there's a lot of information in here. At the very center of our atom, we have a small solid core called a nucleus. Now that nucleus is made up of positive particles called protons and neutral particles called neutrons. Around the outside of this core we have rings. Now these rings hold our third particle, our negative electrons. In an atom, it is the number of protons which decides which type of atom it is. The difference between gold and silver, for example, is given by the number of protons. If we change the number of electrons in an atom, we make an ion. And if we change the number of neutrons in an atom, we have an isotope. This is how an atom is going to be given to you. It will have its chemical symbol here, in this case helium, a small number and a big number. Now the small number tells you the number of protons. This is called the atomic number because it tells you which atom it will be. This number up here tells you how many protons and neutrons are in the nucleus. So here this is number of protons. So in helium we'd have 2 protons in the nucleus. And we'd also have 2 neutrons because 2 protons plus 2 neutrons make a total of 4. Now remember, it is the number of protons that decides which element it is. For example here, hydrogen has 1 proton. Helium has 2 protons. Beryllium has 4 protons. And lithium has 3 protons. The different number of protons mean it's a different element. Now none of these atoms are charged overall, even though there's lots of charged particles inside them. That is because the number of positive protons exactly matches the number of negative electrons in an atom. So the positive protons cancel out with the negative electrons, so there's no charge overall. So in helium, for example, there's 2 positive protons. It would mean that there's 2 negative electrons as well to cancel out. These electrons are arranged in rings. In this first ring, you can fit 2 electrons only. Any more electrons, you have to expand out to the second ring. Now in the second ring, you can fit up to 8 electrons. And in the third ring, you can fit up to 8 electrons as well. Now if you get given any extra electrons in your NCEA exams, you can just draw them into a 4th ring, which isn't shown here. Now we can write down this order of electrons. It's 2 in the first shell, 8 in the second shell, and 8 in the third shell. This is called your electron configuration, just the way that the electrons are arranged in their shells. We can write this shorthand as well, as 2, 8, 8, meaning there are 2 in the first shell, 8 in the second shell, 8 in the third shell, and if there are any left over, we'll put them in the 4th shell. Let's have a look at magnesium now. Now magnesium will have 12 protons, and must have 12 neutrons as well, because 12 protons plus 12 neutrons makes 24. We also know that the number of protons is the same as the number of electrons in an atom. This one has 12 protons, so it must have 12 electrons as well. So if we put those in our atom, in the first shell we can fit 2. In the second shell we can fit 8. Now so far we've used up 10 of our 12 electrons, so our remaining 2 will go in the third shell. This will give us an electron configuration of 2, 8, and 2, and can be written exactly like this. But something strange happens to magnesium a lot of the time. These outside 2 electrons just drop off. That is because atoms love to have a full outer shell. In the case of magnesium, the easiest way for it to get a full outer shell is to lose these 2 electrons. That's much easier than gaining 6 electrons to fill up its third shell. When this happens, this makes an ion because we've changed the number of electrons. Now an ion is when an atom has gained or lost electrons in order to have a full outer shell. In the case of magnesium, there were originally 12 positive protons that were balanced out with 12 negative electrons. But now we've lost 2 electrons. We only have 10 negative electrons now. These 10 negative electrons will cancel out with 10 positive protons. However, we've still got 2 positives left over. This means that magnesium, once it's lost these 2, will have a charge of 2+, because the 10 doesn't balance out with the 12 anymore. This is called the magnesium ion, because it's lost electrons. Looking at carbon now, carbon as an atom will have 6 protons and 6 neutrons, because 6 protons plus 6 neutrons makes 12. It won't have any charge up here because it hasn't gained or lost electrons yet. That means it will have 6 electrons as well, 2 and then 4. Now we've looked at what happens when we change the number of protons. The atom changes, and changing the number of electrons means that we have an ion. But if we change the number of neutrons, say in this case from 6 up to 7, the charge doesn't change and the atom doesn't change. This mass number up here just changes. Or if we change it up to 8 numbers, this would go up to 14, 6 protons plus 8 neutrons. This means that when we add or take away neutrons, we're not changing anything except for the mass. It's getting heavier when we add neutrons in, and it's getting lighter if we take them away. These don't contribute anything to the type of atom, and they don't contribute anything to the charge. They simply add or take away mass. Now, isotopes are the same atom with a different number of neutrons. In this case, carbon with 6 neutrons, carbon with 7 neutrons, then carbon with 8 neutrons are all isotopes of each other. Now, different isotopes have a different mass. That's because we've taken away or added in neutrons, which have mass. But the charge and the type of element stay exactly the same. Alright, what you need to know from this video. You need to know that there's a solid center in the middle of an atom. This is called the nucleus. The nucleus is made up of positive protons and neutral neutrons with no charge at all. There are rings around the atom which are filled up with negative electrons. Now all these gaps in here are just purely empty space. Now the electron configuration is the way these electrons are arranged in the shells, arranged in these rings here. In this case it would be 2, then 3. You'll get given atoms like this in your periodic table. Now the big number is the mass number. This is the number of protons plus the number of neutrons. This number down here is the number of protons. This dictates what element it is. The number of protons and the number of electrons are always the same in an atom, but they are different in an ion. Now, if we change the number of protons, we have a whole different element. If we change the number of neutrons, we get a different isotope. Change the charge or the type of element, it only changes how much mass there is. And if we change the number of electrons, we have an ion. Now atoms often try to gain or lose electrons so that they can have a full outer shell. A full outer shell means that they are stable. Right, let's try a question now. Explain why the ions formed by sodium and oxygen both have the same electron configuration. Now we're talking about ions. That means these are atoms which have gained or lost electrons in order to get a full outer shell. Now if you look on your periodic table, sodium is 11, it has 11 protons, and oxygen is 8. So let's draw these out now. Here's sodium, it has 11 protons, that means it will have 11 electrons as well in the atom. With oxygen, we have 8 protons, and so we'll have 8 electrons in the atom. Sodium's arrangement, there will be 2 in the first shell, 8 in the second shell, and only 1 in this outside shell. Oxygen will have 2 in the first shell and 6 in the second shell. Now, they both want to have full outer shells. That means it's easiest for sodium to lose this one outside here, to get a full second shell. That's much easier than trying to gain 7 electrons around the outside. This will give it an overall charge of +1, because there'll be 1 proton now which isn't balanced out by a negative electron. Now oxygen over here, it's easiest to gain 2 electrons to fill up its second shell than it is to lose all of these 6. So if it gains 2 in here, it's gained 2 negative charges that aren't balanced out by the positive charges. So that has a charge of -2. Now back to the question, It asks us to explain why these ions have the same electron configuration. They both have the electron configuration of 2,8. This is because they form ions to gain a full outer shell. You could expand on this to say that sodium loses an outside electron, and that oxygen gains 2 electrons. This means that they have their full second shell.